Hey YouTube, I recently experimented with fluorescein and other fluorescent colors. I just wanted to show you how the experiment I did went and what I got out. Now, to create fluorescein, you need resin, phthalic anhydride, and zinc chloride. You can also use phthalic acid, but normally it's easier to get phthalic anhydride. So you use a burner. I use an ethanol burner because the flame is not as hot as a gas burner. And then you just heat it up. Heat it slowly and carefully because otherwise you could get burns on it. So be a bit careful and wear safety glasses. Fluorescein as a color is pretty cool. It's non-toxic, it is very colorful, it fluoresces under blue light, and it's pretty easy to make, and you can find it almost anywhere from text markers to fluorescent signs to other stuff. Now, as you can see, the resin begins to melt and reacts with phthalic acid. The zinc chloride is only a catalyst, but it gets absorbed in the solution as a whole. Now, the dark red thing is fluorescein. Make sure nothing stays behind in the test tube but fluorescein and a solution of zinc chloride. I guess the temperature in the test tube at the moment is about 200 degrees Celsius. That's not too hot. You could do it without a burner and just use electric heating systems, and it would be just fine. Now, you see there are white particles in the test tube, and those white particles are just zinc chloride that couldn't get dissolved. It doesn't matter if you get it in there, just be sure that it reacts to a bit of hydrochloric acid with water, so don't bring it onto anything that isn't resistant against it. After heating it, pick a part of aluminum foil and pour it onto it. Now, as you can see, it's steaming hot, so let it cool down for a while. Now that I had created a bit of fluorescein, I wanted to do some experiments with it and see what happens if I mix it with different substances. To make fluorescein fluorescein, you need to mix it with water. I just used distilled water or H2O and tried to pour it into it. As it turns out, fluorescein is really like a rubber, so it's quite hard to get it off the foil. I ended up scraping it off with a chisel. Now, dissolve it in the water, and you'll see it turning green almost instantly. The green stuff is called urinin, and it's what fluoresces later. Fluorescein is not good dissolvable in water, so you might want to add other stuff like lye, which makes it better, or ethanol. I use a 50% water, 50% ethanol mix here, and it doesn't work too well. So add a bit of lye after mixing it. You can see it fluoresces under normal light yet. Now I'm adding the lye, and the fluorescence is getting much stronger. Notice that the fluorescence is green, so it makes a brownish tone. But if you look on the side of the glass, it's brown, and if you look on the top of it, it's more green. Also notice that my hand fluoresces because I got into the color with it. It's quite an interesting effect. Not something you see every day. Now, I just scooped out the solid compartments of the glass and then went on to filter the rest. Filtering is a very easy technique. Just use a test tube, a filter, and pour the stuff in it. As you can see, the filter fluorescizes too. That's pretty cool. Now, after we got a part of it down, the filter begins to submerge in the liquid. If the filter is submerged, it won't filter anymore, so you need to elevate it a little bit. Now, that's enough for the moment. After filtering it and cleaning the workbench, you can see there's a very special effect with the stuff in the glass. I wanted to see what happens if you heat it, and it turns out it takes a really long time to heat it, longer than water. If you heat it, it turns non-transparent after a short while, and it stops fluorescizing almost immediately. I guess the heat destroys the color particles. Also be careful, because it seems to be sticky, and so vapor could build up under the liquid and throw it out. See what happens. Yeah, not the best result of everything, and don't put your hot test tube into a plastic test tube holder. So I cleaned everything and prepared another vial, and this time I'll be adding hydrogen peroxide. Now, hydrogen peroxide is very interesting because it causes us to fluoresce really hard and really extreme. You can see it starts almost immediately. It turns non-transparent after a little while, but it fluoresces really brightly. Now, after a short while, you can see it even fluoresces under dim light. Now, the third vial, I filled it with hydrochloric acid. And hydrochloric acid seems to stop any kind of fluorescence. It turns transparent. It's a bit yellowish, but it doesn't fluorescize anymore. Now, that's our normal liquid. That was hydrochloric acid. That was the H2O2, and that's heated. Interesting, isn't it? Thank you for watching.